Welcome everyone to our next lesson in trig. This is lesson 13, angles of rotation. Now, this lesson is more of a setup of what's to come. So there's actually no trig in this specific lesson, but again, it is setting up for the next few lessons. So bear with me. And I actually think you guys are gonna like this lesson. It's kind of a little break in the trig unit. So this lesson is angles of rotation, and today you're going to understand angles in standard position. So our first concept is standard position. So angle theta, which I'm going to label here on our first image, is right there. This is in standard position. The vertex right here, this is at the origin. So I'm going to label this our vertex. And then we have what we call the initial side. That's this guy right here. The initial side is always on the x-axis. It does not go anywhere. And then finally, as you can see, we have one more ray that forms the angle. This guy, if I can draw it nicely, which I may not be able to do, and actually I'm not even going to try. This ray right here, this is called our terminal side. And this is the one that moves. This side is what we're going to be moving, and we're going to be doing some drawing and spinning and some fun stuff. And this all comes to angle rotation. So there are 4 quadrants on a coordinate plane. So if we look here, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So yes, the quadrants move counterclockwise. When we talk about angle rotation, we're rotating the terminal side. So this one here that I just talked about. So recall that one full rotation is 360 degrees, and half of a rotation is 180 degrees. So if we come here, we start on the x-axis, so we start at 0 degrees. Half of it is 180, meaning half of the half is 90. So each quadrant is 90 degrees, and then we come full circle here back to 360. A big thing to note is we do have positive and negative rotations. A positive rotation moves counterclockwise. So if we start at x at 0, if we go counterclockwise, that is a positive rotation. And then a negative rotation is our normal clockwise. We still start at the same spot, but now we go clockwise for a negative rotation. So you guys will have to use this information about angle rotation to estimate. That's what we're going to do here for these next few examples. The first type is drawing one. And when I draw my angle, I first like to lay down my 0, 90, 180, 270. So that way I get a better approximate. So 120 degrees. We start at 0 and we go past 90, but we're not going to go past 180. So it's in between 90 and 180, and we have to do our best to estimate. And I think it's about right here, and we're going to draw our terminal side. And there you have it. We have drawn 120 degrees. Now, negative 30 degrees, I'm going to start with labeling, but this time I'm going to go, because it's negative, I'm going to go clockwise. So 0, negative 90, negative 180, negative 270. So now when I draw, I start at the x, or I'd start at 0, And then we're going to go negative 300, negative 90, negative 180, negative 270, and then just go a little bit past. And there we go. And then finally, 470. This one is bigger than 360. So yes, you can have multiple going around. So since it's positive, we have 0, 90, 180, 270. All right. So we go one full rotation is 360. So now we need to know, all right, how much is left? So we're going to do 470 minus 360. And we just have to go 100, whoops, not 1,000. We just have to go 110 more degrees. So where we left off, and we keep going. So just a little bit less than where we put 120. All right, so that is us drawing. Now they're going to give you a drawn angle and you have to estimate where it is. So I'm going to still start with labeling. So 0, 90, 180, 270. So here it falls in quadrant 2. It's closer to 90 than it is 180. And halfway in between would be about 135. So we're going to kind of back up and I'm going to estimate that it is at about 115 degrees. Now on your homework for Delta Math, they're actually going to be pretty nice. They're going to give you a range that you just have to be within 10 degrees of where it lands. So this could potentially be like 120 degrees or 118 degrees. You have some wiggle room on Delta. All right, so this one, so 0, 90, 180, 270. So it's in quadrant 3. It's way past 180, but it's not quite past 270. So I'm going to venture a guess, and I'm going to guess 265. That is a really slim area that it has left to go to 270. So I'm going to guess 265. So that is drawing an angle and estimating an angle. So now we're going to continue our work with a new concept called coterminal angles. So coterminal angles are two or more angles in standard position that share a terminal side. Now, I'm going to show you what I mean by this. So we're going to start with a 45-degree angle. So 45 would land me right here, right in the middle between 0 and 90. And then let's also do 405 degrees. So we're going to start here. We go a full 360. Oh, and look at that. It lands me right at 45. Please note that they should be lining up. I'm just terrible at drawing it. And then say we have negative 315. So now we're going to go the opposite way, and it's going to land in the exact same spot. So these are all the same angle. Meaning, because they all land in the same spot, they are coterminal angles. So to find a coterminal angle between 0 and 360, you will need to either add or subtract 360 degrees. Sometimes you may need to add or subtract more than 360 to get it in between 0 and 360. So our find coterminal angles, so 735. So that is way larger than 360. So what we're going to do, we start with subtracting 360 and see where that gives us. So coming over here to my calculator, 735 minus 360. As you can see, it gives us 375. That is still not less than 360. So we have to go another round of subtracting. So we're going to minus, whoops, clear, 375 minus 360 again. And there we go, 15 degrees. That is between 0 and 360. So this is where we would stop. All right, our next one, negative 280. So we need to get it between 0 and 360. So this one, we are going to add 360. Let's see where that lands us. So negative 280 plus 360, 80 degrees. And look at that. We only had to go one round of addition, and we have it between 0 and 360. So there we go. And then finally, our last concept for angles of rotation, and this one's actually a pretty big one, is reference angles. So what this means is when an angle is in standard position, so let's just draw one right now. So let's put it right here. So here is my terminal side, here's my angle. The reference angle is the acute angle formed between the terminal side and the x-axis. So what we're going to do with this terminal side, we drop a vertical, and our reference angle is right here in between the terminal and the x-axis. It is always in going to the x-axis. So make sure you're using the x-axis to locate the reference angle, not the y-axis. So now, don't worry, I have a couple of tools for you to use to figure out, okay, what do I need to do to find my reference angle? So if your original angle is already between 0 degrees and 360 degrees. Oh, that was a terrible, let me redo that. 0 and 360. Then you guys are going to follow this chart that I'm going to put together for you. If your angle lands in quadrant 1, you will do nothing. If it lands in quadrant 1, your angle is also your reference angle. If it lands in quadrant 2, you are going to do 180 degrees minus your angle. If it lands in quadrant 3, you are going to do your angle minus 180 degrees. And then quadrant 4 is going to be 360 minus your angle. But again, this is only if your angle is already between 0 and 360 degrees. There's a little bit more you have to do if it is not between 0 and 360. All right, so if your angle is not between 0 and 360, find the coterminal angle between 0 and 360. Then follow the chart. So that is what you need to do. If it is not between 0 and 360, you are going to find the coterminal angle and then follow the chart. All right, so here, negative 210. first thing I need to do is I need to see what quadrant it lands in. So negative 210 is going to be somewhere here in quadrant 3. And this is the angle we're trying to find. But because this is not between 0 and 360, we need to first start by finding its coterminal by adding 360 to it. So 360 is 150. So now that it's between 0 and 360, now we follow the chart. It's in quadrant 2. So we're going to take 180 minus 150, and it equals 30 degrees. So this reference angle is 30 degrees. All right, our next one, 545. It is not between 0 and 360. So we're going to start by subtracting 360 to see if that will help. And it does, 185. And I accidentally forgot to draw it. Let's place 545. It's going to be somewhere right there. And this is the angle we're trying to find. So it lands in quadrant 3. So in quadrant 3, we do the angle minus 180. Again, because we had to find a coterminal, we use the coterminal angle, 185 minus 180. And our reference angle is 5 degrees. So there you guys go, angles of rotation.